Okay, hello, welcome everyone to this video. Okay, so yeah, we are going to do today a little bit more about the meshing. Okay, so when we talked last time, we were discussing, I was just showing you some of the snappy hex mesh features with respect to layer addition. Unfortunately, the mesh inside looks pretty ugly, as you can see here. And what does this mesh actually look like? Well, right, let me show you how to visualize the mesh a little nicer. So this is the refined snappy pipe.foam. Okay, let me reload this for you. Yeah, let's have a refined snappy pipe.foam. It can give you a slice plot. Okay, we're gonna go for slice plot. Slice plot, I've been using that a lot. Alright, so we'll use surface with edges. Okay, surface with edges to see what the plot looks like, and you can see it's very ugly looking. If you don't want the plane, because you can select this plane here, right, to move up and down, and it kind of gets in the way of shifting your plot, you can deselect show plane under plane parameters under the slice plot over here, and you will be able to see all the relevant details without getting that plane in the way. Alright, so that's generally speaking how you can get it to work. Okay, let's do 90-degree turn. Alright, yeah, so okay, the plots look very ugly. Like I said, looks very ugly, and the idea is that, okay, you want to see what the cells look like. Alright, there are a few things you can do. So go to plane parameters and go under, and you click this thing called crinkle slice. Okay, crinkle slice under properties. Just scroll down roughly halfway through. If you're on Paraview 5.7, you will see this under plane parameters. Put crinkle slice, and what you will see is this rough shape of what the mesh actually looks like. Alright, what each cell looks like. So you can see there are lots of tetrahedral looking cells. I mean, it's not as bad as all the triangles that we saw, but there are lots of tetrahedral cells over here. You can see tetrahedral cells. Some that look really awful, some are okay, but generally the cells are tetrahedral, and maybe we want a way of smoothing these things out so that they don't cause problems later on. However, all the cells in the middle, they don't look too bad. As you see all these triangle things here, they're not as bad as it looks once you got your crinkle slice on. Nevertheless, there's some things we still want to improve, and that's the point of this video. If you want to get rid of this tetrahedral looking mesh, what can you do? And of course, if you look at the layers at the edge, it should not be much of a problem. If you look at the crinkle slice, all the stuff at the edge, the layers at the edge, they are not too badly formed. Okay, not too badly formed. If you want a second slice plot to show a z-normal kind of thing, that should not be an issue. Oh, that's a clip plot. Don't use a clip plot, use a slice plot. Okay, clip doesn't quite do it. Let's add common slice, z-normal. Okay, we'll use a surface with edges, and of course now we want to put crinkle slice as well. So that, and we'll want to deselect the show plane so that we can see what these look like. Alright, so once we got the crinkle plots and everything on, we can see that everything in the middle looks very tetrahedral-ish. Meaning to say, what's tetrahedral look like? Tetrahedral looks like this. So it's like a pyramid with a let's see. Alright, let's do it this way. Okay, escape, delete. Okay, alright, that's better. Okay, so you visualize a pyramid with a triangle base. All right, pyramid with a triangle base. Pyramid with a triangle base, but these are yeah, this is a tetrahedron. Okay, the tetrahedrons make up tetrahedral mesh. So if you say tetrahedral mesh, it means that the mesh is made up of this kind of shapes, four points or 4 extreme sides. That's a tetrahedron. Hexahedron, which is 6, has a 6-sided. So for example, a cube is a hexahedron. All right. That's the general gist, the general idea. A cube is a hexahedral shape. So, oopsie. Yeah, cube is a hexahedral shape. This is a tetrahedral shape. Now these kinds are okay for finite volume, very good for FEM, but more or less in general we might want smooth edges, more circular like things. Maybe it could be better for stability in general. But alright, wow, what's happening? Oh, okay, yeah. Anyway, so yeah, it's important to take note of what's going on. Okay. Oh, Paraview is getting a little more lag. Okay, now it's better. Paraview was getting a little laggy. Was it the temperature? Okay. Oh yes, temperatures are getting high. Perhaps that's why things are not working as well. A little bit of lag here and there. Okay, but anyway, so crinkle plots are like such. Crinkle plots are as such. You can see the tetrahedrals, alright? So we want to find a way to get rid of tetrahedrals and, you know, make the plot a little nicer looking. How can we do that? Okay, so the way to do it, if we want, okay, this is not important now. We want to have this thing called polyhedral mesh generation, right? You see, we have a tetrahedral. This is from the OpenFOAM wiki. We have a tetrahedral mesh, all right? But we want to convert it into something smooth. Okay, so this is tetrahedral. You want to convert it into a mesh with maybe smooth edges, more looking like spheres, and that's where you have your polyhedrons. So these ones look slightly nicer. Okay, perhaps better for stability because they look more like cubes or more like spheres. So maybe that's a better thing, and that's what I'm trying to do. How do we do this? Well, we'll try the polyhedrons. Okay, so let me see. And for this particular mesh, okay, or mesh utility, you will not find many guides, maybe a few forum posts. Okay, and what you will find, okay, polyDualMesh. Okay, polyDualMesh. Oh, I think I will not crinkle the slice anymore. I don't want to crinkle the slice too often, if not this thing start working very hard. Okay. Woo. Let's see sensors. My CPU is working really hard. But anyway, let's get back to topic. Right, so we'll have a polyDualMesh, basically, and there's very few documentation bits about it, and most you will find the API guide, and that itself is not really helpful. It says it creates a dual of a polymesh adhering to all feature and patch edges. Okay, great. What's that supposed to mean? Okay, so the polyDualMesh is the tool we want to discuss and use. All right, that's the thing we want to discuss and use. Hey. All right. Anyway, yes, good. Looks like it's a little more cool. All right, I'll do this later. Anyway, polyDualMesh. All right, polyDualMesh is as such. You just use the tool like so, and we want the help in full. Okay, so it says that you need to do polyDualMesh options. You can do your override as before. You can use the documentation, and you can also do source code. You can display the source code, doc source, as you can see here. So if you're not sure, you can copy this link and you just paste it here. Okay, let me try copying again. Copy link, paste. Alright, so this is our source code in the browser from the OpenFOAM C API. So this is what polyDualMesh, the C++ file, looks like. Alright, I'm just going to open both of them for you. Alright, so what's it do? You take a look at the H file, the polymesh.h. It will roughly tell you what to do, or what it's doing. Yeah. So, okay, it's a lot of data. Remember, I found it somewhere. Okay. It's in the description here. Description: creates dual of a polymesh. So every polymesh point becomes a cell on polyDualMesh, and every polymesh cell and patch face becomes a point on the polyDualMesh. So what's it talking about? Okay, so if we delete this, alright, let's draw a little tetrahedral-ish looking shape. So 1, 2, 3. So tetrahedral mesh looks like a lot of triangles together, yeah? Okay, that's what tetrahedral mesh tends to look like. Lots of triangles. Okay, so I'm not going to draw everything, but what polyDualMesh does, okay, I'll use a different color here. Okay, alright, let's use maybe a green. Okay, we use a green color. So let's look at all the centers of this. Alright, so there are 6 centers in this triangle looking like shape. So if you join these centers together, so these are actually cell centers, right? Now the cell centers, what are they saying? The cell centers, every polymesh point, okay, every polymesh cell and patch face becomes a point on the dual mesh. So what's it mean? Take a look here. So every cell center, so these cell centers become the edge. So when OpenFOAM says point, it means the edge. All right. So and it says also every polymesh point becomes a cell. So where are the polymesh points? Okay, they are actually at the edges of the tetrahedron. So these are called the points. So all of these will become cell centers. All of these points where I circled will become cell centers, and all of these points in the center of the tetrahedron, they will become the cell, what do you call it? The new cell centers. And the old cell centers will become new points, as you can see here, and the old points will become the new cell centers. So they kind of do this kind of inversion thing, and that's what a dual is about. This is what a dual is about. All right. And what do you notice here? You notice that the tetrahedron shape sort of becomes a sort of a hexagon shape in 2D, but in 3D you will change your tetrahedral mesh. You'll change your tetrahedral mesh into something more looking like this, and you can look. If you take a look at this file in particular, you'll notice that a lot of them look like 2D hexagons or heptagons or what have you not. Okay, so that's what it is doing, and it does give you that polymesh looking cell. All right, so normally over here, a lot of people say, you have to give it you have to give polyDualMesh a sort of angle to work with, a feature angle. Most people, I think I read from somewhere, I'm not really sure where. Well, at least over here, it's in the 75-degree range. So most people like to play around 60 to 80 degrees. I can't remember where I read it, but 75 is a good guess. So let's do a polyDualMesh, and we just put 75. Okay, polyDualMesh, and let's put a feature angle of 75, and then it will start. So you see it will be done really quickly. And what happens? Alright, so I'll just do a reload here. Okay, polyDualMesh, reload, don't skip 0 time. And look at what happens with, look at what happens on the inside. You see this all these extreme angles, suddenly you see you look at all this funny looking things here, they sort of disappear. And when you change it with polyDualMesh, all of this suddenly look more even. You can see that. And if you were to take a look at the slice plot in the z direction, okay, look at the slice plot in the z direction. Again, all of these look more even. It's a very much nicer looking plot, except you see the boundary layers, they sort of get really thin. So that's something you kind of got to think about and mitigate if you want to use this tool. Okay, so again, let me do the crinkle plot again. Let's do the crinkle slice. Alright, so you can see that the crinkle slice for this edge looks a lot nicer. Okay, the points look more even in general. Can you see? The points look more even in general, as you can see here. And if you were to take a look at if you crinkle the other slice, crinkle this slice, what happens is that you see the angles on each of these edges are a lot more gentle, as you can see. Okay, so this is a polyhedral looking like cell. Okay, a polyhedral looking like cell. Of course, you have cells that are like, yeah, very polyhedral, as you can see here. So this is how you can so-called change the snappy hex mesh to make it more polyhedral. Okay, so with dual mesh you can do this no problem. And yeah, and that I was also going through some useful ways of using Paraview, the slice plot. You can crinkle the slice, okay, and you can triangulate the slice so as to remove all these extra lines that are kind of redundant. Okay, so these lines are redundant, we can just remove them. Though if you would actually note the snappy hex mesh version, it is still pretty it's still pretty elongated. So if you like polyDualMesh, I mean, if you take a look at this, the cells look more like cubes or polyhedrons. If you like this kind of mesh, and it's good for your mesh quality, then do consider using this tool. It looks pretty good, and it makes the cells a bit larger. Could use it for better stability as well. Alright, so these are some of the meshing tools to help you get your mesh to somewhat a more palatable state. Alright, so do consider using polyDualMesh. Alright, so that's all. I'm going to write it in. Okay, into FreeCAD style mesh gen, I do the transform points, and then I'll just do polyDualMesh, and I'll just put 75, and I'll put overwrite. Okay, so let's do a remove 0.002. Okay, and then I'll do polyDualMesh 75 overwrite, so that this writes over everything into the 0 directory, into your constant directory, so that you will more or less be using this sort of mesh within your simulation anytime. So look, the stuff, yeah, the mesh does look nice. And remember, you can do crinkle. Use your slice plots. Make sure you do a crinkle slice, or you deselect this, triangulate the slice, so that you can see what the mesh shape actually looks like. And this is how it will look like if you use polyDualMesh. Though do note, again, at the edges over here, the the mesh size is extremely small, so you might want to do something about that. But overall, the mesh everywhere else does look pretty okay. Alright, so thanks for watching. I'll see you guys again. Bye bye.